In this lecture, we will continue our discussion on example on separation into real and imaginary part. If sine alpha plus I beta is equal to x plus I y, prove that number 1 x square cosec square alpha minus y square sec square alpha equal to 1, and number 2 x square sec hyperbolic square beta plus y square cosec hyperbolic square beta is equal to 1. We have given sine alpha plus phi beta is equal to x plus phi y. We have to prove these two identities. So write given sine alpha plus I beta is equal to x plus I y, x plus I, that by using the formula sine a plus b, that is sine a cos b plus cos a sine b, is expand this one, sine x sine alpha, here a is alpha, b is I beta, so cos I beta plus cos alpha sine I beta x plus I. Okay. Next, we will use the relation between circular function and hyperbolic function. That is, in place of cos I beta, I am going to write cos. I will write cos hyperbolic beta and sine I beta. In place of sine I beta, I will write I sine hyperbolic beta. Okay, sine hyperbolic beta. So next step, you should write this one, sine alpha cos hyperbolic beta plus cos alpha sine hyperbolic beta, and in the right hand side it is x plus alpha. Next, equating real and imaginary parts, we get this is the real part in left hand side and this is the real part in right hand side, that is sine alpha cos hyperbolic beta is equal to x cos alpha sine hyperbolic beta is equal to y. Put this equation 1 and this equation 2. Next, we will divide the both side of the equation 1 by sine alpha. In the left hand side, we will get cos hyperbolic beta, and in the right hand side, we will get this one. So that in the next step, it is cos hyperbolic beta x 1 by sine alpha is cosec alpha. Similarly, 2 implies if I divide this equation 2 by cos alpha, in the left hand side I will get sine hyperbolic beta, in the right hand side we will get cos alpha. This will implies sine hyperbolic beta is equal to y sec alpha. Okay, since cos hyperbolic square x cos hyperbolic square beta minus sine hyperbolic square beta is 1, from the properties of hyperbolic function we have got this one. So put the value of cos hyperbolic beta equal to this one and sin hyperbolic beta equal to y sec alpha. We will get this implies x cosec these are square as this one is square alpha minus y square sec square alpha equal to 1. That is we have proved the first part. Okay, this part is to prove the second part. To prove the second part. To prove the second part. Again take one. Again one implies this time I will divide the equation by cos hyperbolic beta. Okay, this will give sin alpha equal to x cos hyperbolic beta. Okay, hyperbolic beta. This implies sin alpha equal to x sec hyperbolic beta. Okay, this is one equation. Put this 3. Again, this time I will divide the equation 2 by sin hyperbolic beta. Okay, then I have cos alpha in the left hand side. I am dividing this equation by sin hyperbolic beta. Then this is in numerator and denominator. Sin hyperbolic beta will be cancelled out. I will left with cos alpha. In the right hand side, I have this sin hyperbolic beta. And this is equal to y. 1 by sin hyperbolic is the cos hyperbolic. Okay, this implies cos alpha is this one. Since sin square alpha plus cos square alpha is equal to 1. Therefore, put the value of sin alpha, that is this one, and cos alpha, put this equation 4. So, using 3 and 4, we get sin alpha is by this one, x square sec hyperbolic square beta, and cos square alpha is this one, y square cosec hyperbolic square beta, and these are equal to 1. So second identity is this one is also proved. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.